Okay, so we're going to do a little video here in preparation for Chapter 5, iRAT. Here are the topics that you need to be familiar with, and let's walk through these. The first question is, what is known variation? 5.1 talks about what is variability, and it breaks it down to this idea of known and random variation. And it gives an example here, firm A. Firm A is where the variation is known with 100% certainty. And then firm B and C are different categories of random variation. What are the sources of demand variability? There are some sources overall of variability here. There's variability in the process time, variability in delivery time, variability in the quality of the product. But in addition to these types of variability, there's also variability associated with demand. So the sources of variability in demand, or excuse me, the sources of demand variability can be found in section 5.4, talking about variability in stationary demand, variability in demand with trend, and variability in demand with seasonality. And the sources are customers making independent decisions, each having a different probability of needing the product each week. That's where the variability comes from in stationary demand. The source of variability in demand with trend has two main sources, natural variability and variability due to increase in demand. And then the sources of variability in demand with seasonality is the cyclic behavior. This seasonality is another source of variability, which occurs specifically in seasonal demand. Ice cream, cold drinks, bag of ice, etc. Okay, the variability in demand per unit time and variability in inter-arrival times is talking about measuring variability in demand. So section 5.4 and 5.5, specifically 5.5, talks about the two different ways that variability can be measured. And it goes through two different examples here. It gives the examples of order arrival times to a pizza shop with three different scenarios. Maybe that could be 3 different days. And then it also provides variability in the demand per unit time. Let's see, let me show you the other example here. So one is the pizza shop example. Another example is, I believe it's a bakery at a grocery store. Where'd it go? I think I lost it. Yes, so in 5.5.3, 5.5.3, there's an example about a supermarket that orders fresh bread from a local bakery. And to prevent stock out and to decide how many breads to order each day, the manager would like to know the variability in demand for the bread. Question is, which variability measure is critical to the manager? The number of customers who buy bread each day, demand per day, or the variability in inter-arrival times, they want to buy the bread each day. And it goes on to say that the local bakery is interested more in daily sales, but the pizza shop example is more interested in the inter-arrival times. And so this section talks about both demand per unit and inter-arrival times. In a pizza shop, which the main goal is to minimize the flow time or order waiting time and its corresponding costs, the variability in inter-arrival time is more critical. From a supermarket perspective, they are more interested in the number of orders per day, which is demand per unit time. The variability in the number of demands per unit time is more critical than variability in inter-arrival times for the supermarket. The next question is dealing with reservation systems to book flights. This is talking about scheduling demand. So 5.6.1 says strategies to reduce variability in demand. One of those strategies is to incorporate reservation systems. And it talks about why that's significant here. So that's where this is. Why use reservation systems to book flights? That's going to help reduce variability in demand. Let's see, the next topic here deals with the sources of variability in the main tasks. So where does variability come into play in the main tasks? And in section, what section is this? 5.7.1, it says the sources of variability in the main task: human performance, job condition, task complexity. The next question is, what is natural variability? Which is right below this. Natural variability. Natural variability of an activity corresponds to the variations in the theoretical process time of the activity, which is the time to perform the main task. So these are the embedded or the included variation that happens just in the main task. This natural variation. How to calculate the coefficient of variation. This is also in this section. The CV is the coefficient of variation. It is the standard deviation divided by the mean. We see that also both from a theoretical perspective. This is a theoretical main process time. And we also see that from an effective perspective. That same formula can be found here too. An effective variability, the coefficient of variation is the standard deviation divided by the mean. The mean time, mean effective mean process time. And this is the standard deviation of the effective process time of the activity. That is the coefficient of variation. So standard deviation divided by the mean. Next question is how to calculate availability. We've seen that before in chapter 4. There's a little bit of a refresher here. Availability is the mean time to failure divided by the mean time to failure plus the mean time to repair. That is your availability. If there is no failure and no repair time, then availability is 1. Otherwise, it's usually a ratio of less than 1, 95% or 90% or 85% availability, based on the mean time to failure and the mean time to repair. Next is how to calculate a machine's effective mean process time and effective capacity using a theoretical mean process and availability. This is actually talking about this equation right here. So, to calculate the mean effective process time, which is TEFF, mean effective process time, we can use the theoretical process time divided by the availability to get our mean effective process time. That's that equation right there. And then, as we know from chapter 4, the way we turn that into a effective capacity is we do 1 divided by the effective mean process time. Finally, the principle of frequent versus less infrequent interruptions. And the principle here is also in this section. If we scroll down to the bottom of this section, the principle is more frequent but short interruptions result in lower effective variability than less frequent but long interruptions, given that capacity is unchanged. And it talks about this in pretty good detail. So that is the principle of frequent versus infrequent interruptions. I hope this video is helpful. I invite you to consider the entire chapter, chapter 5. There's some really, really good information here. But in terms of preparing for the iRAT and TRAT, this should help. Okay, we'll talk to you later.